Okay, we're going to practice more on our rectangles later on our 6-4 sheet, but notes for today, we're going to cover rhombus or rhombi for plural, like Mr. Ware said earlier. It's kind of like cactuses. We don't really say, right, we say cacti. So rhombus is kind of the same. If you have a, yeah, it'd be kind of weird. So this is a rhombus. This is a picture of a rhombus. A rhombus is a parallelogram, right? It has these same 4 properties that we wrote up here at the top, but it also has 3 more. So what makes them so doggone special? Can you, just by looking at this picture, maybe give me something that a rhombus has that not every parallelogram has? Or just something you notice about the picture? It kind of looks like a square. What part about it looks like a square? No. Squares are, I mean, squares have something. Squares are a little bit different. Why? It looks like a square that has been like tilted. Okay, so tell me, what are some properties that it has? Yeah, well, and look, it's got all these 4. Like, a rhombus has all 4 of these because it is still also a parallelogram. So we're not going to repeat any of these 4. Okay, in addition to those 4, opposite sides parallel, opposite angles congruent, consecutive, supplementary, diagonals, bisect. There are going to be 3 different ones. I'll give you a hint. One of them has to deal with the sides, the 4 sides. Just make a guess, y'all. Look at the picture. Tell me about the 4 sides. No, the sides of the rhombus. These 4 outer sides. Yes, hello, children. All 4 of them are the same. In a rhombus, all 4 sides congruent. In a rhombus, all 4 sides are congruent. Now, the other 2, you probably will not be able to come up with on your own, so I'm going to help you there. The second one is that diagonals bisect pairs of opposite angles. Opposite angles. Sorry for the blinky screen. I'm sure it's going crazy. Diagonals bisect pairs of opposite angles. So I kind of want to break down what that means. What does bisect mean? Cut in half, good. Can you name me a pair of opposite angles? Yeah. C and A. If angles are opposite of each other, that means you can draw an arrow from one completely across to the other. So A and C are considered opposite of each other, and D and B are considered opposite of each other. Okay? So with this, when it's saying diagonals bisect the pairs of opposite angles, that means angle A and angle C are cut in half by the diagonal. Okay, so perhaps if I put that this is 30 degrees, then that also means that on the other side of angle A, if it's cut in half, it must also be 30 degrees. It would be. We haven't talked about squares yet. We're going to talk about that next. But instead of being like, here it's 30 and 30, what are the angles of a square? They make right angles, which are 90, and I heard somebody say it would be 45, 45. So that's the thing, is that rhombi, or they look like tilted squares because their angles are not the same. So here's the other deal. In a parallelogram, we also learned that opposite angles are congruent to each other. So if angle A is congruent to angle C, then what are these two angles over here by angle C? 30 and 30 as well. Okay, and if the four angles have to add to 360, we could figure out what the other angles by D and B are. We could also do this. Let me tell you the third fact. There's something else about the diagonals. The diagonals are perpendicular. What does that mean? Intersect? How? Give me a number. How many? Are these lines perpendicular to each other that I just drew? But intersecting doesn't, intersecting does not always mean perpendicular. These are not perpendicular to each other. These, what do you mean? That's the number I'm looking for. 90-degree angles. Perpendicular means 90 degrees. So look what that means. That means at their intersection here in the middle, we can put four little boxes to show that, or one box rather, to show that those are all 90-degree angles. Now, this is going to be the key to doing rhombi well. Someone said earlier they noticed that rhombi were broken up into 4 triangles. So if I focused in on, like, let's look at the bottom triangle. No, it would actually, well, it could be scaling, but I don't know for sure. Let's look at the angles though. One of its angles is 90. Another one of its angles is 30. Can you find the third angle? 30, 60, 90, right? It's got to add up to 180. So I know that this angle has to be 60 because these 3 angles must be 180 altogether. Now, what if I use this second fact for that 60-degree angle as well? It says diagonals bisect pairs of opposite angles. So that must mean angle B was cut in half. So if the bottom part of its angle is 60, then what is the top part of its angle? For angle B. If angle B was cut in half, then that means its 2 sides are the same, or 2 angles are the same. So that means it's 60 as well. And then because it's also a parallelogram, opposite angles are congruent, which means angle D is the same as angle B. So I'll give you a hint. In a rhombus, what I like to do is I like to draw, if you group these 4 angles, do you know how all 4 of those are 30 degrees? And if I drew it the other way, if I circled my diagonal in the other direction, all 4 of those angles would be 60 degrees. Does that make sense? Yeah, Ms. Schwanier, totally makes sense. Thank you, Patrick. All right, so there's a rhombus for you. Last shape we're going to talk about for quadrilaterals right now is a square. Now, a square is a parallelogram, right? It's got opposite sides are parallel and congruent. It's got opposite angles are congruent. Consecutive angles are supplementary. Diagonals bisect. So a square has all of these. But it has 5 more things. So tell me what makes squares special. What? Hold on, one at a time. Waylon, what did you say about equal? Okay, so let me write the angles. The first thing is that not only are the angles equal, but do you agree that all 4 angles specifically are 90 degrees? Okay, and their sides are also congruent, and for a reason that I'll show you in a second. I'm going to write this in the third blank. All four sides are congruent. Very good. The other three have to do with the diagonals of a square. So just kind of maybe make a guess of what you feel like the diagonals do or look like. Say again? Did you call it a midpoint? Yes. So I don't know exactly which one that would fall under, but I'll say that I think it would fall under this. The diagonals are congruent to each other. So if they are congruent, then Travis, you're correct. That would actually mean that, so we know the four sides are the same in a square. If the diagonals are congruent, that means E is the midpoint. That means AE is the same as EB, is the same as ED, is the same as EC. So those four little sections would be the same. And what about, we said the angles earlier, like in a rhombus, you know, we talked about the opposite angles like D and B. In a square, if all four of the angles are 90 the four corner angles are 90 degrees, what do you think the two smaller angles are at angle A? Yeah, and that's true because of the fact that diagonals bisect pairs of opposite angles. Okay, there's one more thing. It's dealing with the diagonals. Look at the intersection of those diagonals. Can you make a guess? Awesome. So the other way of saying that is that diagonals are perpendicular. So what I want you to do is I want you to look at these 5 traits of a square, and I want you to look at the traits for a rectangle and a rhombus and tell me if you notice anything. What are the same? So which ones from this list are the same as a rectangle? The first two. So these two are the same qualities for a rectangle. And we just learned about a rhombus, and these 3 were the qualities of a rhombus. So if a rectangle and a rhombus had a baby, they would name him square. Because a square has all the properties of rectangles and rhombi. Kind of neat, right? Yeah, totally super neat. Okay, today's task is going to be to finish your, what is it, 6-4 or 8-4? 6-4 rectangle sheets. So yesterday I started you off with a couple. Today, so I did 2 with you in the middle and I did a couple with you up top. I'm going to give you a hint to one of a different type that you're going to see. And ideally, we're going to have over 30 minutes left. So ideally, you should finish this today. If you kind of get caught up in class, it's okay. You can finish it for homework. If you finish, right, which I don't recommend. Did you get one, Austin? So this is what you missed yesterday. It's doing the top part. So you could either copy over someone's top part, or there's a video on my webpage. That's basically yesterday's class that I recorded that you could go watch that as well. I mean, yes, y'all's voices are in the video. Can you get decimals? Is that what you asked? Yeah. Yeah, I think so. No, they don't. You're right. I'm looking at it now. Okay, before I cut you loose though. I want to kind of give you a hint for number 11. And number 11 and 12. Okay, so let's look closely at 11 and 12. Okay, 11's what? What about number 9? Why? You have it on your paper. X equals 12. Yes. A to either one of the other ones. So it doesn't matter. So that's the thing, is like 7 is a little bit different because you have to look at, like, 7 is saying, and that's why I like to use a highlighter. For number 8, it asks you for UZ. So I highlighted U to Z. Number 7, what is the question? Like, ultimately, what are you solving for? Find US. U to S is the entire length of a diagonal. Number 8 was just half of that diagonal. Sure. Sure. No, not multiply X by 2. You have to plug X back in and go solve because they give you the lengths of parts of the diagonal. So you plug X back into one of the other ones. Sure, there you go. Okay, the only other hint I'm going to give you is number 11. So if you want a hint, pay attention. Okay, number 11 says, if the measure of angle SRT is X plus 9. So again, I'm going to kind of shade where that angle is and put X plus 9 on the outside. SRT. The other angle is the measure of angle UTR. So if I connect the dots, U to T to R is this small angle here. It says that is 2x minus 44. The question is, what is the measure of angle UTR? Well, UTR is this red portion, but in order for me to find that red portion, I have to figure out what x is. Hey, are y'all listening to me? I know. That's why I'm pausing here for a second. Okay, the question is UTR, which is the red stuff. But in order for me to find the red stuff, I have to find what X is first. So can someone tell me what they know about these two angles? The blue and the red angle. Is there something that you know about them? Yeah, perfect. Good job, Patrick. If you extend, this is a parallelogram. If I extend those parallel lines in my transversal, Patrick hit the nail on the head. Those are, except instead of using the word opposite, we use alternate interior angles. And we know that alternate interior angles are the same. They are congruent. So to start you off for number 11, if they are the same, then you're going to set them equal to each other. So there's your hint for number 11. Okay, so look, your job today, we have just shy of 30 minutes left, is to finish 6.4. If you don't finish, you can finish for homework, but we know nobody likes homework. So try to knock it out now. Mr. Ware has the answer key. So as you work, you can go ask him if it's correct, or if you're stuck, you can ask him for help. I'm also here to ask for help. If you happen to finish early, you can go ahead and turn the paper in to him, and he will trade you for the worksheet on squares and rhombi that we're going to do in class tomorrow for you to get a head start on that one. Capiche? Capiche. All right, get busy. Oh, I need to upload the video.